All right, we are moving on to lesson 3. So lesson 2 was more on your own. And if you didn't fully understand lesson 2, we'll kind of repeat a lot of the same stuff from it anyway. Just remember, it's your responsibility to make sure that note sheet from yesterday is uploaded. That's how I hold you accountable on sub days, to make sure that even if you were off task in class, that you're still making up the lesson on your own time. All right, so use function notation to talk about function is our main goal today. So you'll know that you're successful if by the end of this lesson, you can describe connections between a statement and function notation and the graph of a function. And then if you can use function notation to efficiently represent a relationship between two quantities, and use statements in function notation to sketch a graph of a function. So based on what you did yesterday, what is function notation? All right, how do I say something? How do I even just say this? Anyone remember? How does that pronounce? What is it? Ryan, I think you said it. F of x. Good, thank you. It's not f times x. It is f of x. It's basically saying function of x. X is usually your what? Input. And then what's usually your output? F of x. Good. But like in a table or like on a graph, what letter do we use? Y. So basically, what you learned before, outputs are your y's, right? Now we're just replacing it with the word f of x. So that's why I kind of use that definition, f of x equals y, because that's what it is. That's your output. It's just a fancy way of writing it so that you can clearly see what the input is. Make sense? So if I have the coordinates, I don't know, 3, 4, how would I write that in function notation, you think? So don't shout it out yet. All right, now discussing your groups, how would you write the coordinate in function notation? All right. Think which one's the input, which one's the output, where does it go? All right, so show of hands if you have an answer. How would I write that in function notation? Perfect. That's really it. All of that practice just to basically be able to read stuff when it's in function notation. I should clearly see my input and I should clearly see my output. Good. So I'm recording right now, just like always. Great for reviewing and rewatching once we get close to the unit tests, but really primarily I do this for students that are absent. But why not make it available to you as well? The puzzle piece will be lesson 3. Lesson 2 was yesterday's task. It was only 4 questions yesterday. So hopefully you got that done. If not, I guess in total you have like 9 sessions today. So really not bad at all. I do have tutoring today until 3 if you want to stop by. And here's the upcoming assessments and deadlines. So we will be testing kind of like a benchmark, the Horizon math test during class on Tuesday. And I'll later on tell you how that will be graded, because I do count it as a grade. Because if I don't, then you guys just guess and think like it doesn't really matter in the long run. Of course, I won't grade you on stuff that I haven't taught you yet, but if it's something that we've covered, I do expect you to show that you know it on the benchmark. So just make sure like there's no like study guide for it. It's really helping you practice for that ACT Aspire test, which as you just heard again in the announcement, is tied to gradebook. So consider that. I wouldn't bank on it completely in order to pass the class, like still shoot as high as you can, but the grade bump would apply to both semesters, so you want to do well on that assessment. But then other than that, our first quiz for unit 4 won't be until after lesson. So questions on anything? All right, so now let's kind of warm up. This is not on your paper, on your note sheet. This is more just kind of checking your understanding from yesterday. So you'll notice today you do have kind of like a whiteboard. It's not like a traditional whiteboard. It's a laminated paper, right? And a sock. If you have your own whiteboard marker, feel free to use it. Otherwise, I do have some extras over here in this bin. Just send one person from each team if none of you have one. And you're just going to kind of discuss this in your groups. Try it yourself first. Even though it's not printed, you can just jot it down. Remember, function notation is super short. You can just jot it down on your note sheet, you answer it, and then transfer it onto your whiteboard. So any questions on what we're doing? Okay, so then based on this graph of the function of x, you're going to find f of -4, f of 0, f of 3, and so on. All right, I'll give you about 5 minutes. All right, table 2, what is f of -4 equal? Oh, that's you guys? Okay, table 2. It equals 2. Anyone disagree with that? All right, how do we know table 2 that f of -4 is 2? What do I look at? So you looked at -4, which is the input. Where do my inputs go? On what axes? Okay, so look at where my input's -4. And then how do I know what my output is? Until it hits the line, right? Because that coordinate there is -4, 2, my input, which is my x, and my output, which is my y. Make sense? So that's a lot shorter than me saying, like to say f of -4, than me saying find the y when x is -4. All right, that's the whole reason they do function notation. It's just shorter. All right, so then table 1, what is f of 0? All right, 0, any disagreements there? All right, when x is 0, so is y. It is not x times 0. It's just looking on the line that is drawn. Table 5, what about f of 3? I can't remember which one. Oh, it's not. So what's my input on this one? 3. What's my y when x is 3? All right, any changes, class, that we need to make to this answer? Make it a negative, but otherwise it's good. It's not exactly on the 2, it's a little bit above. So -1.8 is a good approximation. Let's see. Table 8, what about f of -5? So it's knowing how to read the function notation. What can I clearly see in function notation? -5 is the input. What's my output when my input is -5? 0, good. Thanks for helping me. All right, now why are the last 2 a little bit different? What is it asking you to solve for now? The x, which is my input. So what are they giving you? They're giving us the Y, or in other words, they're giving us the output. So find the 2 on the Y-axis. And what's a possible X that I could have when my output is 2? Landon? -4. Can there be more than one answer? Yes. So -4 and what else? About. All right, I heard 2 different answers. I think I'm leaning more towards the -0.8 because it's not like right in the middle of. All right, it's a little bit closer to the -1. So questions on that? Why is there 2? There's 2 inputs that have the same output of 2. Good. So they both cross right there. Last one, table 3. What is X when f of X is 0? 0. All right, perfect. All right, so when Y is 0, there's also technically one more answer. What else? -5. Is this a function?
Yeah.
All right, why do you think so?
Well, basically, what was that other one that I said to? Alright, so for E, basically, that would be a function because they have the same output.
Okay, what's the rule for function? Because it's good, like, to figure out if it's a function, you do look at the inputs and outputs. But what's the rule for if it's a function or not? That's actually from lesson 1.
Every input has an output.
Every input has exactly one output. So do we have any X's that repeat? Technically, no.
Oh,
All right, we haven't gotten to something yet called the vertical line test, but technically, no, every X has exactly one Y. Some of the Y's have this like different X's, but that's okay. We just the X's not to repeat. Questions on this warm up? All right, this one was like an extra warm up to kind of just check our understanding from yesterday while it was gone. Now here's for lesson 3, a similar warm up. We have a graph that represents function f, which gives the height of a drone in meters after t seconds of leaving the ground. Decide which function value is greater. This also is not printed on your paper. You can put your answer either like in the margin or on your whiteboard. All right, this time we're using this graph. Anyone not know what a drone is? Okay, so then based on the height of the drone, after t seconds of leaving the ground, determine which function value is greater. All right, so show me your answers in 3, 2, and 1. All right, looks like we're saying f of 4 for the most part. I don't see anyone with f of 0 up. So then table 1. How do we know that f of 0 is greater, or sorry, that f of 4 is greater than f of 0? What do we look at? Okay, because these 0s and 4s, and like the numbers in the parentheses, always represent your what? Inputs. So inputs, you look at what axis? So then looking here, you look at on the line for the 4 and for the 0. But how do you know which one's greater if there's no numbers on the y-axis?
The other one is higher.
The other one is higher. Good enough for me, right? Because as you go higher on the y-axis, what happens to the numbers? Good, they increase. So for this one, it's definitely f of 4. You might also see it like this. F of 4 greater than F of 0. Just so you know. Right, they're just showing which one's greater. Next one, show me on your board, so rotate clockwise. The whiteboard. And marker. Next person, write down whether F of 2 or F of 5 is greater. All right, clockwise is like the normal way of clock goes. So the clock looks like up here. The way that it hits, okay, to the right. All right, show me your board in 3, 2, and 1. Okay. All right, I see a lot of the same answer. I see 2 correct answers though. So this one was kind of a trick question. Why? Because they are equal. All right. Why are they equal, you might ask? What's the value of F of 2? I mean, we don't really know, but it'd be up here. What's the value of F of 5? Also up there. So they're on the same level, they're on the same plateau, so they are equal on that. All right, rotate the whiteboard again. This time answer number 3. Is F of 3 or F of 7 greater? Right, if you have 4 in your team, everyone just have a chance. All right, down F of 3 or F of 7. And show me your board in 3, 2, and 1. All right. F of 3 is the consensus. Let's see if you're right. F of 3 is here. F of 7 is down there. So higher on the y-axis, the bigger the numbers are. So it must be F of 3. That's correct. All right. So why, like, what's going on in this graph? Why did it like increase, stay the same, and decrease? Because they landed the drone toward the end. So that makes sense that like 7 seconds after it took off, it might be lower than 3 seconds initially. Make sense? All right, now that last one's a little weird. F of t or F of t plus 1. What does t represent? Time in seconds after it leaves the ground. So decide which one's greater, F of t or F of t plus 1. And this should be the person who hasn't written. I think we have 4 people. Right, 50-50 chance. Any, I don't know. It kills me when I grade your test and it's multiple choice and you don't even pick one. All right, show me your board in 3, 2, and 1. All right, most of you chose F of t plus 1, which I can see why you chose that. This one kind of just depends. So that's the answer. It depends what t is. If this was a linear function, like the graph continued to increase as we went on, then yeah, I would agree with you that t plus 1 for sure would be greater. But in this one, it depends because we had it increasing, staying the same, and decreasing. So if I plug in like F of 3, for example, that would be greater. If I plug in F of 7, it might not be. It just depends. So the answer for that one is it depends what t is. All right. It could be greater than, it could be less than, it could be equal to. It just depends. Because if we pick like two pieces that are on the plateau, then it might not be the same. Does that make sense? All right, but good job. You guys got the general gist of it. That last one was a hard one. All right, moving on to the next activity. This one is printed on your note sheet. So the whole goal of this lesson is to be able to interpret function notation, right? So now I'm going to throw a new situation at you. The function pictured on your notes gives the number of people in millions who own a smartphone years after the year 2000. So first, think about it to yourself, maybe write it down first. What does each equation tell us about smartphone ownership? P of 17 equals 2,320 and P of negative 10 equals 0. Right, so think about it first, maybe write it down. This is first part, number one. What does each equation tell us about smartphone ownership? Knowing that it gives the number of people in millions who own a smartphone versus the years after 2000. Okay, I'll take volunteers for part A. What must the P of 17 represent? So what does a 17 represent? Well, you have two options. The function gives the number of people in millions who own a smartphone, or the years after the year 2000. Yes. It is the year. So what must the 17 represent? What year? 2017. So in 2017, so then this must be the number of people that had smartphones. Was it just 2,320? Do you think that that makes sense? 2017 wasn't that long ago. Do you think only 2,000 people had smartphones? No. So how many people is that actually? So if you times this by 1 million, because that's what this says, number of people in millions, you'll get your answer. It's about 2.32 billion. Actually. Doesn't that make more sense? All right, so million has 6 zeros, billion has like 9 zeros. But if you take that number times it by a million, that'll actually give you your value. If that was a struggle for you to figure out which is which, remember what we did in lesson 1. Your inputs, your X's are usually independent or dependent. All right, what about your Y's? They're usually independent or dependent? Dependent. Remember that little trick I showed you? You can make a D out of the Y-axis and not the X-axis. So does the number of people who have smartphones affect what year it is? Or is it the other way around? The other way around, right? So time is independent of the number of people that have smartphones, right? You can't change the time. All right, independent stuff, usually on the X-axis, that's usually your input. All right, now discussing your teams if you haven't already. What must P of negative 10 be? All right, table 8, what must P of negative 10 be? All right, if we said that the inputs are years after 2000, what must negative 10 be? Table 6. 1990, good. Normally, we'd say there can't be negative time, right? But it's not really negative, it's just minusing from the 2000, right? So whatever the input is, you add it to the 2000, if it's a negative, it's a subtract. So what is that 0 representing this time? Nobody had phones or smartphones released in 1990. Does that make sense? Yes. I don't think they had smartphones back then, according to them. So good, nobody had smartphones. Now do the opposite. Be able to write now in function notation, and this I will have you put on your whiteboards and show me. A and B for number 2. So in 2010, the number of people who owned a smartphone was 296,600,000. In 2015, about 1.86 billion people owned a smartphone. So convert that into function of be about 1 minute to have both on your whiteboard. If they're right or wrong yet, you'll help me figure that out. Here's one answer I saw for A. They had P of 10 equals 2966. Thoughts on that? Did they get the input right? Yes, 2010 was 10 years after 2000. Any disagreements on the output? Yes, Jalen? All right, so Jalen says there should be a decimal between the 2 sixes, and she is correct. Because what should the output be represented in? In millions is what it said. So if you're ever unsure, you could take that value, because I know it's hard to convert when you're going from like billions or thousands or something of that sort. If you're ever unsure, just take your calculator. Hold on, the menu won't move, so give me 1 second. All right, but take your calculator, take that number, and since it wants it in the millions, and you multiply it by 1 million, which is 6 zeros. See if it matches what it's supposed to represent, right? And if you're getting something in scientific notation, well, here's a quick lesson on scientific notation. If it's times 10 to the 9th power or something positive, you're basically moving that decimal 9 spots to the right. If it were 10 to a negative power, you would move it to the left. So if this was your answer and you moved it 9 spots to the right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, fill in those spaces with zeros. Is this the same number as what was printed on your paper? All right, no, there's 1 extra 0. So then see what happens if we put that decimal that Jalen said. Now, is it what's printed on your paper? Yes. So if you're ever unsure, that's something you could try. All right, good. Now, I did see your boards for the second one. Here's one of the answers that I saw. So it was P of 15 equals 1.86. All right, do we need to make any changes at all to this? Is the input represented correctly? Yes, 15 is 15 years after 2000. Earlier, I did have, and I didn't see it in here, but just in case anyone thought so. Earlier, they did it like this. What year would that actually be? Given this situation. it would have been 4,015, right? So that's why you just want to represent it in the constraints that they give you. So I didn't see that in here, but just want to point that out. Now, what about the 1.86? Is that good? All right, read it a little closer. It says 1.86 billion, and our outputs are represented in the millions, right? So how can I fix that? What's the difference in zeros between billions and millions? 3 zeros, correct. Here's 1 million. Here's 1 billion. So if I take this decimal, I'll move it 3 spots, because that's the difference in zeros. Would I move it to the left or to the right? To the right. So really, it would change to 1,860, but that's represented in the million. That's how to properly represent it. So questions on that? Okay, almost done. So May is curious about the value of T and P of T equals 1,000. What would the value of T tell May about the situation? And it's for a possible value of T here. So again, just interpreting function notation. This one we can kind of do as a thought. So do we know what our input is on this one? No, do we know what our output is? So 1,000 and then represented in millions, right? So if I times that by 1 million, we're adding 6 zeros. So what value is that actually? With that many zeros. Not a trillion, but a billion. All right, because billion has 9 zeros. So this is saying that there was a billion cell phones at that time. Could 4 be a possible value? So discuss that within your team. If my output is 1 billion, could my input be 4? Given what it represents. All right, Brooks table, what would an input of 4 represent? 2004. Do you guys think that in 2004, a billion people had smartphones? I mean, I don't remember back that far. I'm sure some of you weren't even born yet, but let's look at our given data. So in 2017, we had about 2.32 billion. In 2015, we had 1.86 billion. So do you think it's logical that in 2004, we had a billion already? What about in the year 2010? Did we have a billion yet? No, we didn't. We had way under that. We had 296 million-ish. So in this one, given the data we already have, I would say no, it's not a value. Because in 2010, we didn't even have a billion yet, not even close. Does that make sense? Okay. So now gonna kind of give you some exposure to something you'll see on a test. So you all have this graph on your paper. Using the information that we've talked about so far, sketch a graph of the function. So what points do we know for sure are in this function? Give me 1 point. negative 10 and what? Or sorry, you said 10. All right, 10 and 296.6. We know because it's in one of our descriptions, right? And we transfer that to function notation. So I should be able to plot this one and a few others. So on your papers, plot the other ones as well. All right, so 10 on the x-axis is my input. 296.6 would be about here, because what are they counting, or maybe not there. Because what are they counting by? Technically 200. Each sig mark is 200, right? So 296 would be close to 300. That would be between the 200 and 400, right? So mimic this process with the other points that we know for sure are part of this one. I see that we're pretty much finished now. What other points do we know are for sure on this graph? What points do we know for sure on this graph? Like you guys gave me. Okay, so the 2017 are really just the 17 comma what? What's the output when the input 17? 2320. Right, it's right here in example A. What's another point that we know for sure is on the graph? 15 comma what? 1860 actually, because remember it's in the millions. And then there's one more that we know for sure is on the graph. This one. Negative 10 comma 0. So if you got all those, great. If not, make sure you transfer it over. We know because that's what they told us in the problem. And some they told us from descriptions, and some they told us in function notation. All right, but we figured it out, we transferred it. And then this is what it would look like on your graph. So just make sure that you correct it if it's wrong. So negative 10, 0 would be here. 15 up 1860 would be like right here. And 17 up 2320 would be like here-ish, I think. Would this be a continuous graph or a discrete graph? Continuous, why? Do you think people ever stopped having phones? All right, no, people always, there's always going to be people that have smartphones unless they make something better. So these would technically be connected. Not really sure in what way, but given the 4 dots we have, it might look something like this. All right, questions? Okay, just making sure you have that in your notes. It's definitely continuous. Good job today. Make sure whatever